Hi guys, today we will be looking at Docker. This is our first video in our Docker series, so we'll look at the basics. Let's start off with what exactly is Docker. So, Docker is a system that allows you to build applications that are independent from your operating system. So, the way it works is you get your normal Python app, you build it, main.py, you build a Docker image from it. So you get the Python compiler, you get every single thing into that image, right? We'll discuss later what an image is. So you get everything into that image, right? And afterwards, now that you have the image, you can take that image, put it into any machine. It would run flawlessly, right? Maybe not flawlessly if it's like extreme use cases, but most of the time it should work, right? And this means that once it's in a Docker image, the application is now OS independent and hardware independent for most of it, unless you're fiddling with low-level CPU stuff, in which case you would build multiple Docker images for different CPUs. For example, if we go Node.js Docker image, okay. So this is kind of like if you use JavaScript, it's like NPM, or if you use Python, it's like pip, Maven, all that is, you can put all your Docker images. It's like GitHub for Docker images. Okay, right. Okay, I'm looking for that nice, Docker list. Yes, here. So can you see here? They build the same tag version, so you have tags are nothing but the version control for images, right? So this is all the same, Node.js image, just different tags, different versions. One's Alpine, one's current Alpine, 319, and inside each one of them, they build for many different architectures, right? Most of these are Linux architectures. Well, they're not architectures, as you can see, they're ARM, they're CPU architectures, not OS, CPU ones, right? So that's what Docker is and what's the perks of it, right? It's OS independent. You can run it on, now you can take this machine, you can take this image, you can run it on any platform. Node.js, you can run Node.js on Windows, Mac, Linux, server. Even if I have a weird CPU, if I have an Intel chip, you just get the correct one. Sometimes these are specific ones because, they're fiddly with the actual processing. But if it's, not fiddly, like, for example, I have put some Docker images, right? Like this one here. It's not really fiddly, right? It's just one size fits all. Anyone can use it. Any machine, any architecture could use it, right? So now let's look at what an image is. So, for example, in an image, let me get canvas. Okay, right? So assume we have an image, right? Blue pen, like blue. Okay, this is our image, right? What would be inside our image, right? We'd have several stuff. So let's assume we're building a Python app, right? Python image. First of all, we'd need the Python compiler, right? As I showed you before, if we're building a JavaScript one, we'd need the node image, this guy, right? Well, for Python, we can just search Python. We get this, right? We'd mention we need Python, right? Right? What else do we need? Our source code, right? Obviously. We need our source code. src. I can't write well in this. We need our source code. What else do we need? We need something called a Docker file, right? What is a Docker file? A Docker file is literally the set of instructions. So when I say image run, that image will look to the Docker file. Okay, what should I do? What do they want me to do? So it's basically the images. For example, like pip install, get all the dependencies. You can build your project, or you can just straight away run it. You can run some different stuff, you know. So Docker file, right? Just put a D, I can't be bothered, right? Docker file, we need that. Okay, so that's what an image is, right? It's just your application containerized. No, it's just your application frozen into a kind of like a state. The state could be run. So all these guys, they're images, right? Docker Hub, these are all images, right? Every single thing is an image, right? Many big companies have gone to use Docker Hub, right? PyTorch is using it, TensorFlow, a lot of AI guys, and in fact, it's become one of the most used ways of hosting. No one really just hosts a single instance of a machine. They use something called Kubernetes. We'll come into that later. So, what next? Now, when we run this Docker image, assume I get, for example, MySQL. I run it. Docker pull. So this is how you can get that image into your local machine. But in order to do that, you would need an account. So when you're creating an account, right? I don't know which one to go to. All that. So when you're creating an account, right? You can get different versions of your account. You can get Docker Personal, Docker Scout, there's a premium one, and there's an enterprise one, right? And there's also a free one, which I'm using right now. So the only issue with a free one is you can't make private images. You can only like 1 or 2 or something, you know. You can only make 1 private image, or 3, I think it was 3, I don't know. But yeah, private images. So that's one perk of the paid version. But okay, we're drifting. Okay, going back, right? When you have an image and you want to run it, it creates a container. So it kind of like, think of it like this. Your image is a blueprint, right? A blueprint. A simple paper, a blueprint, right? What's that? Okay, your image is a blueprint, right? That blueprint, you take it, and then you build an instance of it. Your blueprint is untouched. Your instance is running. Now, what you can do is you can take another instance. You can take 1,000,000 instances from your blueprint. Your blueprint is the image. Instances are many containers. These containers are, you know, you could destroy them. You could create them, you could start them up. They're not really that important. So that's what makes it good for these auto-scaling. So let me quickly explain what auto-scaling is. So assume you have a React app, right? 1,000 people go visit that React app, the website, right? If you have one single machine, one single instance, it's gonna like go crazy because like 1,000,000 loads on it, right? Whereas if you had, for example, 1,000,000 containers from your blueprint, right? Your one React image, you get 1,000,000 blueprints, right? It would, yeah, basically one person. The load on a single container would be less. Got it? So assume it crashes, right? You won't need to, okay, let me clear the server, let me reinstall stuff, let me redo this. You can just destroy the image, get your blueprint, get another one. But this is untouched. No matter how many stuff you do, it will never be changed unless you publish a new version. Even that you can roll back. So it's just pretty much untouched, right? And your containers, right? So just create brand new containers whenever one fails. Like that, you know? So containerized application. So we call it containerization when we, you know, containerize an application. So as you can see here, you have your infrastructure. This is your like your CPU, your hardware stuff. You have your operating system and the kernel. These guys talk to this guy here. And now on top of that, you have a small Docker world. The Docker, he's like an independent guy. And this Docker now has many containers running. App A, B, C, D, E, F, right? We can have many more, and each of these apps has an image. But these guys right now, they're not images, they're containers, right? Abdi, they're all containers. They could all be from the same image or just, 5, 6 different other images, right? So those are what containers are, right? And yeah, that's pretty much what containers are. Let's check out how to install it. So if you just go install Docker, right? Install Docker Engine. Yeah, just click on your thing. Linux. You go here. You have Ubuntu, Red, Debian, Fedora. Yeah, you can just do like this. Install like this. Follow the steps in and let's go Windows. Most likely get an exe or something. Yeah, you download that exe, or you can just install from the command line, right, like this, and PowerShell stuff here. Yeah, and then it starts your wait, so this is going differently. Let's come back to that, right? I'm talking about the command line. For example, let me show you what the command line looks like. Here's my terminal, right? Clear. Okay, ls. If we type docker, this is the command line, right? The cmd we were talking about earlier, right? Docker -v. That's our Docker version, right? Now there's another guy called the GUI, right? We call him Docker Desktop, right? He's loading. Give it a second. So we'll discuss in another video on the commands, right? As you can see, there's Docker pull, which we saw here when we wanted to pull an image, right? If you want to pull, Docker pull, that's the command, right? Here are all the stuff. Docker build, this is how you build an image from your Docker file. Okay, here's Docker Desktop. It's the same thing, but clicking buttons, a lot of buttons. Create an image. You can't create an image from here, but you can run an image. For example, I have a Discord bot, Traum. Let me run it. You can have container stuff. So there are volumes. What are volumes? Volumes are just external storages. For example, I told you that containers can be destroyed, right? Shut down, paused, stopped. But what if you want real data in it? Like a MySQL database. You don't want to stop it and then literally lose every single data you got. So, you could set up a volume for it, right? You can basically a pointer to a real location in your hard disk. So that when it shuts down, it's all done, you have that volume there, right? An example is I have an image called Minikube. I had an image called Minikube, right? I don't anymore, I don't know why. Okay? So, yeah, so this is our image here. Come on, what are we doing? Okay, right? So, you could set up a literal location to hard disk so it saves whenever you stop it. envs. You could also pass environmental variables through here too. You can pass it through a million places, and this is another one of them. Ports. As I said in the Docker file, that is where all the ports are configured. The instruction set. And also you can set a container name, but they get quite creative and give us a random name if we do not provide one, right? That's everything there is here. If we run it, we get all the logs. So this is the script running. We have a terminal, we can access all the files inside of our container. So as you can see here, most of it, so this is our Docker file. The bin boot, I do not know what they are. Most of everything from here onwards, except sbin and some other service stuff, they are my source code. So if we want to go to files, it gives us like a literal GUI, right? I don't know what that is. For example, if you look at something I wrote, index.js. Yes, this is literally source code I wrote. So it doesn't like bundle it like anything. It doesn't bundle it into some weird bytecode or anything. It keeps your code, right? And it just, as you can see somewhere, it would have literally, probably somewhere in one of those, it has a literal Java node compiler. So in this, if we go back, right here, Docker file. Let's see what's in our Docker file. Cat Docker file. Docker file. Doc. Oh my god, is it such low memory? Cat Docker file. Right? It's a very basic Docker file. So I got node 16. Node 16. That's an image. Node 16. Okay, wait. Node. So here, that we got node, our image. There'll be a tag 16. Yep, one of these tags, right? It just pulls the, probably, yeah, one of the tags, right? Most likely this one. Node 16. So, there are some vulnerabilities. Let's ignore that. But, yeah, it pulls that image. So that's what we're gonna run, right? That is our literal engine. So we copied the source code from, so this Docker file is located in my actual source code. I don't know if I can find the repo for it, but assume we build it in our work directory, right? The source code is literally right there. And then it copies everything there is into here, right? And then now it runs, it's automatically triggered, right? An npm install. Now this npm is coming from the node 16, the image we just pulled, right? This image. And then now when we say run the container, what the Docker would do is it will look for this and just run node index.js. It will just run that command literally. And when you run node index.js, you get this. So that's basically like what the container is. Yeah, so that's practically the container. So for example, if we go to Discord, my bot will be online. Okay. Yep. Yeah. Bot active. Cool. So it worked, right? Now, what I can do, I can take this guy, bring it to a Windows machine, right? This is currently Mac. I can bring it to a Windows machine, right? And then it would work. It will work as usual. So now, if we want to look at through the terminal, there's a command, right? Docker ps. Docker ps. That shows us all the images, right? No, that shows all the containers. For example, now can you see Traum? I don't know if you can see that. Can't zoom in here. Yeah, at the bottom there's Traum. This guy here. Take my word for it. There's Traum. And there's a container ID, right? And if we do docker ls, no, forget it, right? So docker ps, that shows us all the containers there are. And now, if we want to stop it, right? I don't want my bot to run anymore. We can just click stop. And, okay, assume that now we stopped it. It's stopping now. We can now, again, start it again, right? But what if the whole container went really bonkers? Someone crashed it, right? And now the logs are going error, error, error. We started again, error, error. We can just delete the image, right? Image is gone for good. But no, delete the container, not the image. Oh my god, the container. Now when we go back to image, our Tram guy is still there. We just create another one. Like so. And yeah, we can just create another one. And then so on. So even though it crashes, we do not need to, okay, let me cut it, let me clear it. Even if like somehow it got bonkers, right? Some file got messed up, some weird thing went, we can just delete it, start from fresh again. New blueprint. New thing from the blueprint, right? We can start it again, right? So that's basically images and containers and the GUI in the CMD. We'll be going into more about Docker images in the next video, such as pushing to the registry I showed you, Docker Hub, and the tags, the commands, Docker pull, all those stuff. We'll be pulling some more images from there, and after that we'll look at some Docker files too. We'll go more into depth on that. But for now, we can stop it here, and yeah, I think it's pretty good. Let me know in the comments if you got anything else you want me to cover. If it's unclear, this is not the only video I'll film on Docker. I most likely will do the series again. Feel free to suggest anything, and yeah, hope you learned something. Cool.